Assalamu alaikum student, this is Maryam, Zaheer, Kiyani, and today we are going to discuss about the atomic structure. In this topic, we will discuss about the following things: discovery. We will not go into much detail about the experiments. We will just discuss about the pioneers of the idea of the atom. Discovery of atom. Later on, we will discuss about the fundamental particles, or you can say that the constituent particles by which an atom is formed. After that, we will discuss about the properties of the fundamental particles. Later on, we will have a comparison between all these fundamental particles. I am basically writing FP as fundamental particle. Later on, in this lecture, we will discuss about the few terminologies which are basically related with the atom, like atomic number, atomic mass, isotopes, and by the end, we will discuss few questions related to this topic which could be asked in the examination. Okay, so moving towards the lecture formally, uh, have you ever imagined that everything around you is made up of what? This is one of the questions which normally rises in the mind, like the food you eat, the pencil you use to write on, the paper, the book you read, the windows, the curtains, the air you breathe in. What is the thing which are basically constructing it? This is one of the questions which comes in my usually the mind of the people, like uh, the kids, like how they are made. This was the curiosity behind the discovery of the atom. Like by then, the scientist just thought and thought, like why is it so? By then, there was a scientist known as Democritus in 450 BC. In 450 BC, he just imagined, like if he start cutting an apple and keep on cutting and cutting, there would be a point that that particular piece of the apple could not be like further cuttable. That point he named uncuttable. Like whatever the thing you are cutting, there must be a point reached like which like if that particular thing could not further be divided. That point the Democritus named as uncuttable, which was later known as atom. But by that time, when Democritus put forward the theory that there is a certain thing which cannot be further divided, then there was a scientist known as Aristotle. He was also a great scientist who was more influential by that time than the Democritus. Uh, and he just rejected the idea of the Democritus and just said that it is just ridiculous that there couldn't be anything which cannot be further divided. But there was. And this idea of the Democritus remained neglected up to the 200 years. But then there was a scientist back in 1800. He was basically a British chemist known as John Duck, which revived the theory of the Democritus and came forward with an idea that Democritus was never wrong. It was never ridiculous. The idea presented back was something which actually existed. Because the Democritus haven't proven its ideas with some or supported his ideas with the uh, experimentation. So that's why the Democritus ideas were not accepted. But the Daltons basically done various experiment, gas tube experiment. There are numerous experiments which go forward by the Dalton, and he presented a theory by name Dalton's atomic theory on the basis of its experiments, and said that there is something which is known as atom. This is basically the atom word was derived from the atomos. And he said that everything in the universe is made up of it's like everything. every substance you use is made up of an atom. Right. So he said that atom is the smallest particle of the universe. Basically, his idea was that there is a combination of the atoms, which because of which there are different combination of the atom, because of which there are different certain substances are formed. That is because you are able to see different substances. Some are soft, some are hard, some have different textures, some are sweet. This is because of the different combination of those atoms, which produce different type of the molecules or compounds. Okay, so because the theory of the Daltons basically was supported by the experimentation, so that's why it was widely accepted in the universe. And this was the first time the word atom came into being. Okay, but by then it was just a theory that was not formulated in the form of the laws, because by then there were not so much instrument by which you can just see a very tiny thing. So this just remained the idea, and no one had known the structure of an atom, like how an atom would look like or something. That was basically later on discovered by like how the structure of the atom, like how an atom would look like, was discovered by later on by the Rutherford. And after that, the Bohr's the more accepted model. We will discuss about that, the experimentation of the Rutherford and Bohr's uh, later in later in this chapter. Okay. So now I am just going to towards the atomic structure. This was a brief history regarding the like how the atom, the idea of the atom came into being. Now moving towards the next thing, uh, talking about the atom. What is an atom? As the Dalton introduced, the atom is the tiniest part, cannot be further subdivided, cannot be divided. Okay, always keep in mind the atom is something which you cannot cut by your knife. It is very very small that you cannot see with your naked eye. Even you can say that this small dot can have millions and millions and millions of atoms. So it is so tiny that one cannot see it with the naked eye. Whenever we talk about the structure of atom, what are basically the things which are basically making an atom? For that, we use the word fundamental particles. That what the particles which are constituting atom would be known as the fundamental particles. So, talking about the fundamental particles, there are basically three fundamental particles. By which an atom is made: proton, electron, and neutron. Okay, whenever like you can see a diagram over here. In this diagram, if you see this part, this is nucleus. This nucleus of an atom is made up of proton and neutron. It has positive charge over it. Why it has positive charge? Because the proton has positive charge. The protons are the positively charged particles, and the neutrons are the neutral particle. And due to the presence of these positively charged particles, there is an overall positive charge over the nucleus, and there are negatively charged electrons which revolve around the nucleus in particular orbits, the orbits which you can see in black or gray. These are known as energy levels or orbit. Okay, so we can say that an atom consists of a nucleus and electrons revolving around the nucleus in particular energy levels known as orbit. Okay, so if we look over the structure, you can predict what should be the overall charge on the or an atom. Whenever we talk about the overall charge, what is an overall charge on atom? The atom would be neutral in nature. Atom is neutral in nature because of the positively charged protons present in the nucleus and equal number of the negatively charged electrons revolving around the nucleus, which cancel the effect of each other and become making an atom an overall neutral. Okay, normally an MCQ is asked in the examination regarding this, that that which of the following fundamental particles would not be deflected by the electric field. Whenever they talk about the fundamental particle, like they would be providing you three options: A, B, and C, and like electron, neutron, and the last one, proton. And they will ask that which one of the particle from these three will not deflected by electric field. You must have been studying in the physics that any particle which carries charge will be deflected by the electrical field. If we see over here, the electron is negatively charged, so it would be deflected by the electric field. Whereas when you talk about the proton has a positive charge, and the positively charged particles are also deflected by the electrical field. There is only one particle which is neutral in nature, that is neutron. Anything which is uncharged in nature, which has no charge over it, will remain undeflected in the presence of the electric field. So always keep in mind, you will mark the answer neutron. So the neutron is the only particle in the atom which will remain undeflected when passed through the electric field or directed towards the electric field. Okay. Moving next towards the fundamental particles. Keep in mind, these fundamental particles are also known as subatomic particles. Whenever you use the word sub, that is something which is present in a very large, which is a part of the very large thing. So subatomic particles, any particle which is a part of an atom, is known as subatomic particle. If we discuss about the properties of the subatomic particles, there are three subatomic particles as we have discussed before, that is the proton, neutron, and the electron. Now first of all, if you look at the proton, you can represent a proton by P and a positive charge over it, or you can represent it by H and a positive charge over it. Okay, so a proton can be represented by P positive or H positive. Okay, if we talk about the mass of the proton, like how heavy a proton could be, the mass of the proton is 1.673 cross 10 raised to power minus 27. The relative mass of the proton, we'll discuss about the concept of the relative mass later on in this chapter. For now, just keep in mind that the relative mass of the proton is 1 and the relative charge on the proton is plus 1 unit. Okay, it is basically 1 plus 1 unit. And keep in mind, plus 1 unit is equals to 1.6022 cross 10 raised to power minus 19 coulombs. Okay, so the relative charge on the proton would be plus 1 unit, and 1 unit is equals to 1.6022 cross 10 raised to power minus 19. Okay, moving towards the next thing, that is neutron. Keep in mind, the neutron is represented by small n, as it has no charge, so you just write a 0 over the top, or you can simply write as small n. but more preferred symbol for the neutron is n, and just write a zero over it in the superscript. Okay, if we talk about the mass of the neutron, that is 1.675 cross 10 to the power minus 27. You have to memorize these masses. And relative atomic mass, relative mass of the neutron would be 1. Relative charge on the neutron is 0, so it has no charge over it. Similarly, we talk about further fundamental about these further subatomic particles, that is electron. Electron is represented by E and a negative charge over it. It has a mass of 9.109 cross 10 to the power minus 31. If you just compare the mass of the proton and electron, electron is comparatively lighter than proton. Isn't it? Like it has a power of 10 to the power minus 27 and it is a power of minus 31. So it is very, very some lighter than the proton. The relative mass of the electron is 0.005 and the charge on the electron is minus 1. Always keep in mind the charge on the proton is equal in magnitude of the electron but is opposite. Like if the proton is positively charged, the electron is negatively charged, but the charge is equal in magnitude. It both has 1.60 cross 22 cross 10 to the minus 19 coulombs of charge over them. Okay, here just keep in mind, like one thing I forgot to tell you previously, that the maximum mass of the atom, maximum mass of atom lie in nucleus. Although the nucleus is very, very small as compared to the whole atom. Like you can say that if you just see a football ground, it's just a spot on the whole football ground. So, but it still contains the maximum mass of the atom as it has protons and neutrons. And we have already seen in this slide that the proton is many times heavier than the electron. So that's why the maximum mass of the atom lies in the nucleus, although nucleus is very tiny as compared to the whole surface area which an atom occupies. Okay, and this mass of the nucleus vary atom to atom. Like this mass of the nucleus basically dependent upon the number of the protons and the neutrons which are present in the nucleus and vary with atom to atom. Okay, always keep in mind, like if a particular atom has 10 protons in the nucleus and 10 neutrons in the nucleus, will have mass different from the one which has 20 protons and 20 neutrons in the nucleus. So the mass of the nucleus is merely dependent upon the number of the neutrons and the protons present in the nucleus. Okay, moving next towards the comparison between the protons, neutrons, and electrons. As we have discussed, as we have discussed about the uh, particular properties of the proton, neutrons, and electrons, we have came to know that the protons are positively charged particles which are found in the nucleus. Neutron neutron is uncharged particle which has no charge and also found in the nucleus. And there is an electron which have electrons which have negative charge over them and are found in the uh, revolving around the nucleus in certain energy levels. So again, the similar point is repeated, that protons are positively charged, neutrons are neutral, and electrons are negatively charged. If we just talk about that, where are they present? If we talk about their location, that where they are present, the protons are present in the nucleus. Anything which is present in the nucleus is known as nucleon. So neutron is also present in the nucleus, so it is also known as nucleon. Okay, and if we talk about the electron, they basically orbit. Whenever we talk about the orbiting around, keep in mind that they are just revolving around the nucleus, just like uh, you can say that a planet which is revolving around the sun in a particular orbit. Okay, so this, for example, like just you can just compare an atom with a solar system. In a solar system, you see that there is a sun around which planets revolve. Each planet has its own orbit. Similarly, in the atom, the center is the nucleus around which the electrons are orbiting, are revolving, and each electron has its own energy level, its own orbit in which it's revolved. So you can say that the electron revolving a particular energy level or orbit. You can say that uh, it an electron is just similar to a planet which is revolving around the sun in its particular orbit. Okay, so further moving on, if we talk about the weight, the proton weight is about 1.672 cross 10 to the minus 27 kg, as we have discussed before. The neutron have a weight slightly higher than the protons. And if we talk about the weight of the electron, it is insignificant, like very, very less as compared to the weight of the protons, as we have discussed before, as it has a weight of 9.90 cross 10 raised to the power minus 31, which is far less than 10 to the minus 27. So that's why we can say that the weight of the electron is insignificant as compared to the weight of the neutrons and the protons. And this is the major reason that the nucleus is heavier as compared to the uh, whole atom, or maximum mass of the atom is contained within the nucleus. You can represent the proton as P positive, by neutron by N, and electron by E negative. Keep in mind the protons only take in part in the nuclear reactions. The nuclear reaction means in which the nucleus participate. Similarly, the neutrons only participate in the nuclear reaction, the reaction in which the nucleus is participating. And the last one is the electron. The electrons are basically the one which are involved in the formation of the various type of the substances which you see around. Okay, without the participation of the electron, you won't be able to see various type of the substance around yourself. Okay, this was the basic comparison between the proton, neutron, and the electron. Okay, next we will discuss about few terms which could be used to identify an atom or differentiate one atom from the other atom. Okay, first of all, we will talk about the atomic number. As I have told you before, the thing upon which the mass of the nucleus of an atom vary is the number of the protons present in the nucleus. Keep in mind, we can identify an atom on the basis of the number of the protons present in the particular nucleus of the particular atom. So number of the protons present in any atom is its atomic number. Okay, for example, if I talk about hydrogen has one proton in the nucleus. So what should be the atomic number of the hydrogen? The atomic number of the hydrogen would be 1. Similarly, if I say carbon has 6 protons in the nucleus. So what should be the atomic number of the carbon? The atomic number of the carbon would be 6. So you can identify by the number of the protons present in the nucleus that this is the atomic number of the substance. How could, like, if you aren't provided with the atomic number of the protons present in the nucleus, you can find out the atomic number using the periodic table. What is a periodic table? We'll discuss this terminology later in this lecture. Okay, so keep in mind the number of the proton present in any nucleus is equal to the atomic number of that atom. Okay, now how you present an atomic number? Atomic number is basically represented by Z. Whenever you say that atomic number, like if I write the atomic number of hydrogen, I will say that hydrogen has Z equals to 1. If I talk about carbon, I will say that it has Z is equals to 6. if I talk about any other species, that will say that it has an atomic number of 7, 8, similarly depending upon the number of the protons present in the nucleus. Okay, so if you just define this terminology, you will say that atomic number is the number of protons present in the nucleus. If you are provided with the atomic number, you can easily identify the number of the protons present in the nucleus. For example, I ask you that if I ask you about that, the atomic number of the helium is 2, and identify the number of the protons present in the nucleus, you will simply say that there are 2 number of the protons which are present in the nucleus. Okay. The next thing we'll talk about the atom, that is the atomic mass. Okay, now as we have discussed before, that the maximum mass of the atom lies in the nucleus, and the nucleus is made up of two things, that is a proton and a neutron. Okay, so whenever you talk about the atomic mass, the atomic mass basically is the sum of the mass of the proton and the mass of the neutron, which is present in the nucleus of that atom. It isn't necessary that the number of the protons is equal to the number of the neutron in the nucleus. Sometimes the number of the proton is equal to the number of the neutrons present in the nucleus, and sometimes this isn't the case. Okay, so if we define the atomic mass, you will say that atomic mass is the sum of number of proton and neutron present in the nucleus of an atom. Okay, so the sum of the number of the protons and neutrons in the nucleus would be the atomic mass of an atom. Or you can also call the atomic mass as mass number. It is basically represented by symbol A. For example, if I uh, tell you that, as we have already discussed, helium has an atomic number of 2. Okay, and I say that it has number of proton is equals to 2, and it will have number of neutron equal to 2. So the atomic mass for the helium would be 2 plus 2, which would be equal to 4. So you can simply use a formula for the atomic mass or mass number. A is equals to number of proton plus number of neutron. Okay, or you can say that atomic mass is equals to Z plus number of neutron. Isn't it so? As we have already discussed now, number of the protons is basically the atomic number. So you can replace the number of the proton by Z. So if you are provided by number of the proton in the question or number of the neutrons, you can easily find out the atomic mass of the substance, or sometimes they give you the atomic mass and number of the protons, and they will ask you about the how many number of the neutrons are present in the nucleus. For example, if I say you that there is a certain species, there is any species X, okay, and it has atomic number of 10, and mass number of 50. And I ask you to calculate the number of the neutrons. What are you going to do? You are simply going to use this formula. Which formula? You are simply going to use this formula. Okay, simply put the values in this formula. How? A, as you know that A is equals to Z plus number of neutron. Put these values in this formula. This would be 15 minus 10 is equals to the number of neutron. Okay, so the species will have a 15 number of the neutrons in it. Although this isn't the case, the atomic number should be something like round about 20, but I just gave you the example. Okay, is it clear up to now? Okay, moving next toward, like, if something they will ask about the number of protons. If they provide you, like they give you that atomic number of a species is 50. So what should be the number of the protons in that species? The number of the protons in that species would be equal to 50. Or if they just give you A, if they say that A for any species is 10 and the number of the neutron in that species is 5, what should be the number of the protons? You have to calculate the number of the proton. What will be the number of the proton? You're simply going to use the formula we have discussed before. A is equals to number of proton plus number of neutron. So A over here is 10, which is equals to, you simply write number of proton plus 5. 10 minus 5 would be equals to the number of proton. So the given species would have 5 number of protons in the nucleus. So in this way, you can calculate the number of the protons and the number of the neutrons or number of electrons present in a certain species. Always keep in mind that the number of the protons in a particular atom is always equal to the number of the electrons, which is revolving around the nucleus. So if someone when asked that if any species has an atomic number of 15, how many electrons would that species will have? That species will have 15 number of the electrons. As I told you before, that the number of the protons would be equal to the number of the electron present in that species. Okay. Moving next, there is one very important thing. That is the representation of an atom. Like how you are going to represent atom. For example, let X could be any atom. I'm just using X as a sample. Always keep in mind that X is any atom. Always keep in mind in the lower subscript, you will write the atomic number, and in the superscript, you will write the atomic mass. Okay, always keep in mind in the subscript, you will write atomic number, and in the superscript, you will write atomic mass. Okay, for example, uh, if I talk about hydrogen, hydrogen has a symbol of H and it has atomic number 1 and atomic mass of hydrogen is also 1. Okay, so how you are going to represent the atom of hydrogen? You are simply going to write hydrogen. In the lower subscript, you are going to write the atomic number, that is 1, and the upper subscript, you are simply going to write the atomic mass, that is also 1. Similarly, if I ask you to do it by yourself or write the symbol for the carbon. Carbon has symbol of C with an atomic number 6, atomic mass of 12. Just write at your own. How you are going to write it? You are simply going to write a C1, sorry, C6 and 12. Okay. Now, further moving on, what type of the questions are basically asked from this uh, representation of an atom? They sometimes provide you with a symbol of an atom like this. They will give you helium 2 4, and they will ask you uh, provide the number of the protons present in the nucleus. So how you are going to identify? As you know that the lower subscript is the atomic number. Here, what is the atomic number? Atomic number is equals to 2. Atomic mass is equals to 4. So what should be the number of the protons? As we know that number of protons is equals to atomic number. With here, the atomic number is 2. So the number of the proton would be equals to 2. Similarly, if we talk about like how you are going to calculate the number of electrons, as we know that number of electron is always equals to number of the proton. So how many number of the protons were there? There were 2 number of protons. So how many number of electrons would be there? There would be 2 number of electrons present in the helium atom. Okay. Next thing, if we want to calculate that number of the neutron, what should be the number of the neutron? We have already discussed about the formula. That would be A minus Z, the atomic number minus atomic mass minus atomic number. If we look at over here, what is the atomic number? The atomic number is 2 and the atomic mass is 4. So the number of the neutrons which would be present in the nucleus of the helium would be equals to 2. Okay, is it clear? Now sometimes the question which came in mind in the when like what why you are writing He, like how could you write He for helium, H for hydrogen? Normally the symbols which are decided for that particular atom is derived is the starting two or one alphabet of that particular species. For example, if we talk about carbon, the carbon has a symbol of C, which is the very first alphabet of its name. After that, for helium, after that, if we talk about helium, helium has a symbol which is basically made up of the very first two alphabets of its name. Similarly, if I xenon, xenon has a symbol of Xe. So you have to memorize the symbol. Normally, they are the initial alphabets of that particular element. Okay. Okay, so uh, we are done with it. How you are going to calculate the number of the protons, electrons, and the neutrons in the particular nucleus of an atom. Okay, so they're not simply going to just provide you the number of the atoms or the sample. Sometimes they ask the question in a very tricky way in the papers, that they will ask like, I'm just going to write the question over here, that there is an atom Z. There is any atom Z. This is not any particular atom from the periodic table, it's just a representation of an atom. So there is any atom Z which has two electrons more than, sorry, two electrons and two protons and two neutrons, more than S16 and 34. Okay, they will ask give the symbol, mass number, and atomic number of the atom Z. Okay, we haven't discussed about like how you can find out the symbol. You can find the symbol or can identify the symbol from the periodic table for that particular species. That this is the atomic number for this atomic number. The species would be this. That you can identify from the periodic table, and we will discuss about the periodic table later. So just for now, I'm just giving you an example of the question that could be asked in the examination. Okay, so if we talk about over here, they have given you that there is a species, any species, which has number of the protons 2 electrons greater than the S16. So that means it would have, this species will have 2 electrons. If it has 2 electrons greater than the 16, then that means proton would be equals to, then we can say that like you can say that if number of electron is 2 more than 16. As we have already discussed that number of electrons is equals to number of proton and number of proton is equals to the atomic number. So over here, the species which is provided, that is S16, has an atomic number of 60, isn't it so? So it will have how many number of protons? That would be equals to 16. And the species which is given has 2 electron more than this. So the species would have 2 electrons greater than 16. So this Z will have how many number of electrons? That would be 16 plus 2, which would be equals to 80. Okay. Similarly, if we talk about the atomic mass or mass number is equals to the number of protons plus number of neutrons. Let me erase this part from here so that I will have space to write. First of all, we have identified the atomic number of species Z. The atomic number of the species Z is 80. Now talking about the mass number. What is the mass number? Mass number is always equals to the number of protons plus number of neutrons. How many number of the neutrons are in this species? First of all, you have to identify that how many number of the neutrons are present in S. You will calculate that in the similar fashion, that the atomic number for the S is 34, the number of protons would be 16, and the number of proton you have to find out. This would be equal to 34 minus 16, which is equals to n. The answer would be 7. 34 minus 16 would be equals to 18. So how many number of neutrons would be in this? N is equals to 18. So S has 80 neutrons, whereas Z has 2 more neutrons than the S. So how many number of the neutrons in the Z? In Z would be equals to 18 plus 2, that would be equals to 20. So what should be the atomic mass of the Z? Atomic mass of Z would be equals to, as we have already find out the atomic number, that is 18, and the number of the neutrons we have calculated is equals to 20. So what should be the atomic mass of Z? The atomic mass of Z would be equals to 38. So the last thing they have asked for is the symbol. We will not write the symbol for the Z, that which atom is it, because we haven't discussed about the periodic table yet. We are just simply going to write it like Z. The lower subscript is always the atomic number, that is 18. The upper subscript is 38, that is the atomic mass. Sometimes in some books this is written like this, 18 and 38, so never confuse this. Always keep in mind the subscript is for the atomic number and the superscript is always for the atomic mass. Okay, till now we have discussed about the atomic mass and atomic number, and we say that the atom with same atomic number would be the same, and one atom can be distinguished from the other by the atomic mass and atomic number of that particular atom. But sometimes there is a case that two atoms have same number of the protons. Now, how you're going to distinguish such species? That there is hydrogen, there are two hydrogens, both have same number of the protons. That means they have same uh, atomic number, but they are not the same in terms of their physical and the chemical properties. How you are going to identify such species? Such species are known as isotopes. Okay. So whenever we talk about the isotopes, always keep in mind isotopes are the atoms which have same atomic number. Now the thing comes in mind that if they have same atomic number, that so they should be same. Why they have different properties? So the thing which distinguishes them is their atomic mass. So the atoms with the same atomic number and different atomic masses or mass number are known as isotopes. Okay, now how is it possible that a, and two atoms have same atomic number but they have different atomic masses? As we have discussed before about the atomic masses, we have already discussed that the atomic mass is the sum of the proton and the number of the neutrons present in the nucleus. So it is possible if that two species have same number of the protons but they have different number of the neutrons present in the nucleus. In that case, they will have different atomic mass but same atomic number. So you can say that like the word iso, so iso means same and top means and top means place. Uh, why they are called the isotopes? As these atoms will occupy same place in the periodic table. What is periodic table? Why it is we are calling it as like these atoms, the isotopes are present in the same place. We'll discuss in the under the heading of the periodic table. Okay. For now, we are just going to stick with the isotopes. So isotopes are such species which have same atomic number but different atomic masses. For example, if we talk about, there are three isotopes of hydrogen. One is known as protium, the other is known as deuterium, and the last one is known as tritium. Protium has a structure like this, a symbol H11. It has structure of, sorry, symbol of H12. It is symbol of H1 and 3. Okay, so keep in mind, any species when have same number of atomic number and different atomic masses, they would be known as isotope and will be placed in the same block, in the same position within the periodic table. Okay, whenever we talk about the isotopes, we can just write the similarities or the differences between them. First of all, I'm going to write about the similarities of the isotopes. What are the similarities? They have same atomic number, which means they have same number of protons in the nucleus, which will mean that they have same number of electrons in the nucleus. Okay, that means they will have same chemical properties as well. If we talk about the differences, like what are the dissimilarities of the isotopes? So the very first dissimilarity is they have different atomic masses, which indicates that they have different number of neutrons, which shows that they will have different physical properties. Okay, for example, let me just give you a few examples of the isotope. For example, if I talk about the magnesium, magnesium is an element. Magnesium has 3 isotopes. Magnesium is basically represented by Mg. It has an atomic number of 12 and have an atomic mass of, okay, I will discuss about atomic mass later. It has an atomic number of 12. That means it will have 12 number of protons. There are basically how many isotopes? There are 3 isotopes of magnesium. Okay, what are the 3 isotopes of magnesium? That are Mg12, 24, Mg12, 25, Mg12, 26. I'm just moving towards the next page. Uh, just let me write this again. Mg12, 24, Mg12, 25, Mg12, and 26. First of all, I'm going to find out that how many number of the protons each have. It has 12 protons. It is also 12 protons. It will have also 12 protons. What is the atomic number for this? The atomic number is for this one is 12. This one is also 12. For this one is also 12. Similarly, if I talk about the number of the electrons, the number of the electrons for this one would be the 12, and for this one would be 12 also. Isn't it so? Next, moving towards, if I talk about the number of the neutrons, how many number of the neutrons are here? Just simply subtract 24 minus 12, which is equals to 12, which is equals to 12. Similarly, what 25 minus 12? That is equals to 30, and 12 26 minus 12, that is equals to 14. If you look at over here, all these three isotopes have different number of the neutrons present in the nucleus. And if you look at their atomic mass or mass number, so which indicates the mass for this is 24, for the second one is 25, and the for third one is 26. So if you look at over here, all these three isotopes will have same number of protons, same number of the some number of the electrons, and same atomic numbers as well. But they have different mass number as well as the number of the neutron present in the nucleus, which basically affects on the physical property of these isotopes. Okay, so we are up with this session. That in this session we have discussed about what we have discussed about. We have discussed about the base. First of all, we have discussed about the discovery of the atom, that who discovered Democritus. After that, we discussed about the like why the idea of Democritus wasn't considered because of the Aristotle, and the word atom was derived from the Democritus, uncuttable, that is atomos. Dalton basically performed various experiments uh, and presented the Dalton's atomic theory, which indicated that atom is the smallest particle of the universe. Every substance in the nucleus is made up of an atom. An atom consists of three fundamental particles, that is proton, electrons, and neutrons. Proton has positive charge over them. The neutrons have neutral, and whereas electrons are negatively charged. After that, we have discussed about the comparison between the uh, properties of the protons, electrons, and the neutrons. After that, we discussed about how can you represent an atom, the atomic symbols, and we have discussed about the few calculations, and by the end we have discussed about the isotopes and how can you identify the isotopes. And keep in mind that the isotopes have same chemical properties but different physical properties. And thank you for your time. Take care. Allah Hafiz.